Okay, okay. So for standard deviation, and this is the formula. This is the formula. Uh, normally, normally in the beginning of this semester, we do not calculate standard deviation this way. How do we calculate? Just briefly, how do we calculate standard deviation? Uh, we repeat many times. Let's say the first time is 12.9%. The next time is 11.5%. The third time is 13.7%. I just to give you a hint. Try to bring your memory back. This was already taught. We repeat many times. We calculated the mean. We calculated the mean. Remember? We calculated the mean. Then we calculate the variance. Then we calculate the variance. How to calculate the variance? Then square root variance. This is a standard deviation. This is a standard deviation. This is a repeating many times. Not many times. Repeating. I don't know. You know what it is. You get the mean, you get the variance, you take the square root. That is the standard deviation. Here, we only have one number. We only have one number. And from this one, not many numbers. Not many numbers. We just have one sample. 2,000 people. That's enough. That's crazy enough. We cannot get another 2,000 samples, get another 2,000 students. Okay. So, how to get this formula? That's way above. How do we get this formula? That's way above our class. Even myself, I don't know how to, where this formula come from. But this is the formula. This is the formula. This formula is for yes or no scenario. It's only for yes or no scenario. You notice it's a proportion. You notice it's a proportion. On Friday, I will give you another formula for the numbers. For example, the salary, average salary. We asked the 2,000 people and get from these 2,000 people, their salary is so and so. The computer programmer, we asked the 2,000 computer programmer, and their average salary is so and so. We want to know the whole world, the computer programmer, the salary situation. That standard deviation formula is different. This formula is only for yes and no, the proportion. Oh. I forgot to drive this home. What's the number? What's the number? I can tell. If you just trust me, it's 0.02. If you do not believe it, you can calculate this, and it's 0.0072. So this is the standard deviation for this study. Now you will bring back this, you maybe second time. 68, 95, 99.7 U. Okay. So normally we use a 95% confidence. So for 95% is a 2. The z-score is a 2. Remember? Remember? That's a big reason we spend a lot of time on normal distribution. If we want the 95% confidence, this needs 2 sigma. Gosh, this maybe should be sigma. Forgive me, okay? This may be sigma. Sigma is for the population. Is for the population. This is for the sample. This is for the sample. Okay. Anyway, we consider this is a sigma. We consider this is a sigma. So this z-score I don't know why they have a star. I don't know why there's a star on the shoulder. I remember this is how the book presents. Anyway, the Z for 95% confidence is a 2. Is a 2, okay? This is 2. For 95% confidence, this is 2, okay? So it means is 12.9% plus minus 2 times this one, 0.0072. And we drive home this. The result is 12.9% plus minus 0.0144. Do you see it? Is that, can you guys see, is that plotting, you guys? Can you see it from the back? So this means 95% of times. So this means this big P, this ghost P, is in this range plus minus. We are 95% confident is in this range. Not 100% confident. Not 100% confident. If you guys know how to wear face mask and without fold on the glass, please teach me. And when I wear it, my glass always gets fold. I'm serious. I think that's a trick to wear it. I'm trying to put the face mask underneath the glasses. Then my ear gets. Anyway, this is not part of statistics. So everybody clear? This is based on the foundation of the confidence interval. The normal distribution. 95 let me help you by doing the last question of our homework. Go to page 285. Go to page 285. Have you done it? Have you done the homework? Yes, very well. It's just a sample of students' answer. So 13.27 is the last question, right? Okay, so looking at the stops, I'm not very good, I don't know much about the stops, but there was a find from the history, from 1945, those stars has a return of 12% with a standard deviation of 16.5%. I have to borrow this space. I have to borrow this space. So is 12%. Okay. Is 12%. Is 12%. So it's many years from 1945 until now. Many years, each year has a return. Okay, some maybe even negative. Some is a little bit positive, but a little bit. Some year maybe is a big positive. So the average of these many years is a 12%. Some years is even more than 12% return. Okay? Some maybe very little. And the standard deviation, they tell you, for this question, they just tell you, not calculated. In chapter 21, you are calculating standard deviation. Like I said, for many years, so each year has a different interest return. So they get the mean, they get the standard deviation. But this, they don't need to bother you. They don't bother you. They just tell you the mean and the standard deviation, which is, for this example, is, what's 16.5%. 16.5%. Okay? So they want to know the range in 95% confidence interval. In 95% confidence. One is 16.5%. For 95, needs 2 times the sigma. Okay? So, is what? Is 12% plus minus 2 times 16.5%. Do you see it? Yeah, the lower side will be negative. This is which means you are losing money. If let's say if this is a 0. So some part will be negative. You are losing the money. And some part like here, that's a very good year. That's a very good year. So let's drive home. What's the result? What's the result? Huh? I can't hear. Can you speak? 12 minus 33. So minus 11% to 45. Minus 21. Minus 21 to 45%. Okay, is this range? Is this range? Is here will be minus 21%. Here will be 45%. So this is the homework. This is the homework. Well, you really know. So you can see chapter 21 and chapter 13. Actually, they are binding together. You maybe feel, wow, teacher, you're jumping from chapter 13 to chapter 21. This is the chapter 13 question. Okay? So, is the plus minus this. It is a question that directly give you the standard deviation, which is 16.5%. However, in this chapter, you have to calculate standard deviation yourself. You have to calculate the standard deviation yourself. Once you get it, it's the same thing. It's the same thing, plus minus 2 times this. I don't mind you write in a range like this, or most people write in plus minus in this format. Do you see it? So, again, these give out a range, not the single number. This gives out a range. This range means in 95% of times, this one is in this range. This one is in this range. That you guys has been made a lot of, I cannot follow. I have to finish my teaching schedule. Okay. Do you see it? Let's go to the chapter 21st, the exercise. Chapter 21 exercise, and page 472. Page 472. Where is 472? And question 21.5. Question 21.5. So, the president of the college says 99% of the alumni. What's going on? 99% alumni support my decision. I fired the coach. These are all true story. These are all on the news. This author is the chairman of American Statistics Society, David Moore. He was, not current. These people doing good work. So I hope you appreciate your book. I appreciate very much the book. I feel so guilty that we are using without copyrights, using his books. If I see him in US, I will apologize to him. On behalf of this damn university. I'm serious. I may see him in US. Yeah. So he said 99% people, he said that 99% of people agree me to fire the coach. He knows he's lying. He's boasting, saying 99% of people support alumni. You know, in US, alumni is very important because alumni donation is the college the money come from. So he said that the 99% alumni support me firing the coach. Then you don't believe him. Then you try to study. You did a research. This can be a very interesting project. So what is SRS? Simple random sampling. So you get there is 15,000 alumni still alive. Harvard alumni. President Bush is Harvard or Yale University. So you randomly select 200 people out of the 15,000, and you ask them, say, sir, do you think the coach should be fired? Do you think the coach should be fired? And how many said it? 66% said yes, he should be fired. Now, you only know the p hat. You know the p hat 1. Okay, one is enough. In this case, the p hat. What's the p hat? What is the p hat? No, come on. What's the p hat? What's the sample size? What's the sample size? 200. And how many said yes? How many? How many said yes? 66 said yes. Fire him. What's the p hat? What's the proportion? What's the proportion? 66 divided by 200. Okay? This is the easy pattern. 33%. Okay. And the college president says 99% support me to fire the coach. And your p hat is 33%. That is the 99% and the 33%. That's very, very far. Is that possible in this range? What population does the interference concern here? Explain clearly what the population P. What's the population P? What is the P here? What is the P here? Without hat, it means the whole alumni. It means the whole alumni. Okay? The population, the first question, what is the population talking about? What is the population is talking about? The population means the whole alumni. We are not related with this college, so it's not our business. We do not belong in that population. Okay? So the proportion P means the whole alumni. The proportion think should fire the coach. The proportion think should fire the coach. And what is the value of P hat? What is the value of P hat? What is the value of P hat? Yeah, 33%. So we can use this to calculate the standard deviation. To calculate the standard deviation, drive this home. After I finish this, then I check your homework. Well, we drive this home. This definitely needs to be done, okay? Otherwise, so how to apply the formula here? How to apply? What's the number here? What's the number here? 200. Good. And here we use decimal, okay? And 1 minus 0.33. Somebody do me a favor, drive this home. Zero point zero zero 24, that's enough. 0.0024. Okay. So this mysterious P should be is 33% plus minus plus minus 2 times. This is very, very important, guys. Okay, you guys had a long, long break. We have to finish this. After brother, you'll be more patient on me here. Okay? So we choose 2 because most of the time we need a 95% confidence. If we want more confidence, then this will be 3. Then the range will be even wider. But if it's too wider, then that's, if you tell me the possibility is from 0 to 100%, then you are not telling me anything. So 2 times this, so means what? 33% plus minus. We should say. I convert this into percentage. Do you see it? support firing this coach is the 33% plus minus 0.5%. It's a 33% plus minus 0.5%, which is a very 95% of time, which means 99%, as the coach, as the president said, is very unlikely. So he's lying. He is lying. Even we make it wider, 99.3%, we change this to 3. We change this to 3. It's a 99.7% confidence. Almost 100% is also a small number. It's also a small number here. So we are, which means 99.7% confident is not this number. Is not what he said. Are you following? Back to, be patient. Back to this. Pfizer. They said 90%. They say 90% are good. Are they lying? We don't know. If you, when we started to inject the vaccine, if you select the 200 people, only 66 people get the immunity. Now after the calculation, then you will make big news. You say, according to my study, in 99.7 confidence is in 33% plus minus. This is the 3 times this should be the 72. It's a 0.72. So in 99.7% cases, this P is in 33% plus minus 1. Let's say it's 1. That would be make it generous. It's only in this range. It's very, very far from the 90%. We keep our eyes open in January. And we got people injected the vaccine. You will see what. Okay. Then we have the homework. I will send in